Hey everyone, so in this video we want to talk about a very important concept, and that is sleeping. Now sleeping we now show in grains because here it makes the most sense for the first time, but keep in mind this is actually a function that is purely coming from the POP system, not specifically from grains. And also we will see a similar concept later on for RBDs, so the whole concept is very important, not only for grains. Now what we have here is a very simple setup. We have our statue here that I scaled properly and converted, and with polyfill I made sure that there are no holes in it, and then I used the grain source, of course, to turn the lady into grains. And then I have a very normal grain setup with my pop grains with a couple of settings. My substeps are only set to 20, so relatively low. Same is true, by the way, for the amount of grains. For a proper rendered version I would use way more points than this, but I want to keep it snappy for the tutorial. And then of course I use pop sprites with a pop color to make it look a little bit like sand. Well, actually, as I said in the last video, a better alternative to pop sprite and pop color is using a visualize properties node, setting the points as spheres to enable, and then an attribute adjust color node set to random. And here you can already choose a sand preset in the ramp if you want. And this is, in my opinion, the most efficient way because it doesn't interfere with your simulation and you can change those settings afterwards as much as you want without having to resim. And then we have a ground plane and gravity, nothing special. And of course, what will happen if I press start is the lady will fall down into itself. So nothing unexpected. Now, the first thing is what sleeping is actually about is when you look at after the whole thing kind of settles and now you can see the points aren't moving anymore. When we look at the simulation time, you can see nothing really has changed. And this is kind of a problem because the points are not doing anything anymore. They're kind of done, so to say, but still the simulation is doing the exact same amount of calculation that it did before. And this is actually the core idea first of sleeping. And as I said, this is something that is not part of the grain system, but you will actually find it in the POP solver under sleeping. I could have shown this to you earlier, but again, in grains, it makes the most sense. So what we can do is we can just activate it, the auto sleep, and actually let's also activate the sleeping color because that shows much better what's actually doing. And as you can imagine, it will automatically put points to sleep if they are under this here, the velocity threshold. So once points stop moving, they will be basically turned off or put to sleep. So let's see how this looks like. If I run this again, you can see so far nothing has changed. The speed is the same, but as soon as some points come to rest, so to say, they will turn red because we activated the sleeping color. And also, and this is actually the most important thing about it, the whole simulation time speeds up significantly. Now, unfortunately, it's not completely zero because, it still has to kind of recognize that the points are sleeping and then ignores them. But it's much, much faster than before. And especially with a lot of points, this can, significantly speed up your simulation without losing any information because, once they rest, they rest. So this is the core first idea. We can turn points off when they're too slow and when they kind of stop being necessary to be simulated. But let's have a look at what actually happened here. So what does it actually mean that a point is sleeping? When we look at the geometry information of my pop object, so here the geometry subcategory, so to say, we get our geometry spreadsheet inside of our pop simulation. And when we look closely, if we would actually compare all those attributes, we would find there's one additional attribute that was created called stopped. So remember this is really important. This is actually the attribute that does all this. And I can show this to you. If I would turn the function off, then this attribute will disappear. So all this function here does is it puts this attribute into our simulation and of course then by itself sets it once the velocity threshold is reached. And you can imagine by default, the first frame it is 0. And then once they start sleeping, obviously this will switch to 1. Let's wait for it for a second. There you go. And now the points are set to 1. Now, why am I showing this to you? Because we can actually use this to our advantage because we can set the stopped attribute ourselves. So one function that we can use, for example, is we can set start asleep, and all that does is it sets the stopped attribute at the first frame to 1, and then basically doesn't do anything with the points anymore. But that doesn't stop us from then changing the attribute value again. So for example, what we could use for this is a pop wrangle. And this is just supposed to show you that you can, use anything you want to just change this attribute. And we could say, for example, I don't know, if for the current position of my particle, if the y element, so the height, is higher than 2, let's say, then just set the stopped attribute. And as we can see, this is an integer, which is important. We set this stopped attribute to 0. So we turn the stopped off or bring the point back alive. Now, if I press start now, you can see that nothing happens. Why not? That's because, actually, let's look at the position of the points. Yeah, okay, I misjudged this. So 2 meters would be up here. So let's change this to 1 meter. And now you can instantly see what happens. Okay, so let's run this again. And you can see we can activate points based on any kind of, arbitrary rule and just set the stop back to 0. So we have full control over this attribute. And the funny thing is now that it actually still will turn it off once it reaches the bottom. So, as you can see, those two can interfere. So you can, maybe if you want, turn the velocity threshold to something really high or something, I don't know. But in our case, this will actually not be a problem. But keep this in mind, this function will still run. So as we can see, this way, we can actually activate only parts of our simulation if we want. And you can imagine what we can use this for. We can actually activate our object over time. For now, to make this look nicer, let's turn off this sleeping color. And instead of a pop wrangle, even though it would totally work in Vex as well, let's use a SOP solver. Because as we know, the SOP solver allows us to use any kind of function that we already know. Let's say we wanted to activate our lady from top to bottom. What we could use, for example, to define this area is a simple group. So let's set this to points and let's call this, I don't know, active group or something. I don't know, it doesn't matter. And then let's use the bounding box region and let's make sure we make it big enough. And then we start up here. Let's set a keyframe. And this is the cool thing. We can set keyframes to our groups as well. And now let's say in 3 seconds, it moves down to here, let's say. Set with Alt another keyframe. Let's see if that worked. Yeah, that worked. And of course, all we have to do now with a point wrangle, we take this group, very important. You don't want to activate all of them. And for only those points, we set the stopped attribute again to 0. Again, keep in mind that stopped by default is set to 1 because while we still turned off the color, we still have the start asleep intact. So if you look here in the geometry spreadsheet, the stopped attribute is set to 1 in the beginning. But since we're now activating it with a group, let's press start and you can see that it's not working. Why not? This might be the SOP solver. Let's look from outside. So sometimes with a SOP solver, you have the problem that when you look from the inside, you don't see the result correctly. So let's go outside of it and have a look again. Okay, and now it works. So this is a little bit of an annoying problem. Sometimes you don't see the actual result of a SOP solver inside of the SOP solver. So keep in mind, we can always just, pin up here to look from this position in our network, and then we can still go inside and change numbers or anything. And now you can see it actually works, and we can actually activate an object from top to bottom. And this is a technique we've seen before in the video about the sub-steps that you need for grains, where we saw from an artist the rendering of a very nice sand sculpture that was breaking up slowly over time. This was using exactly this technique because, of course, you can use more than one group. Maybe you can use multiple input geometries even. So maybe a sphere that only activates a certain area of a sculpture, and maybe the sphere is growing, and you can create really complex activation shapes for this. You don't have to do just a simple group that moves down, but this is something you can do for yourself. I just wanted to show you the concept, and as you can see, all it really is we change the sleeping behavior to start asleep, that means that our stopped attribute is used and is set to 1, and we can use a pop wrangle or geometry wrangle or a SOP solver to just set this attribute back to 0. And in our case, we use a group for this to activate over time from top to bottom all the points inside of this group, and what we get out of this looks like this, which is a really cool effect. One thing to keep in mind here, using the internal sleeping setup while a good starting point can actually create problems, because if you start asleep, you will still have activated the auto sleep. You cannot start asleep without that, which can be annoying because it can result in points that, are activated falling down and then start to sleep again at a point where you don't want that. So, it's not a massive problem, but something that can sometimes be annoying. So as an alternative, you can ignore this altogether and just use the attribute that we just changed directly as a starting attribute. So before it goes into our simulation, we just use, for example, a point wrangle or an attribute create would be fine as well. And we just make sure that our stopped attribute is explicitly set to 1, which will have the same result. And let's call this stopped. And as you can see, even with our sleeping turned off, but a stopped attribute as a starting attribute, we will have the exact same behavior. So just to keep that in mind. I would actually work like that and ignore the internal buttons basically. All that matters is the stopped attribute that we change anyway, and you can set this yourself and it will have the same effect. So go ahead and build your own version of this, potentially much nicer than my version, and I hope this is helpful. So thanks very much and see you later. Cheers.